want you to know about a polynomial. Well, so a polynomial, technically, poly means more than one, right? Multiple. However, the definition for polynomial in a way contradicts that, because a linear function or a quadratic function that's like y equals x squared is a polynomial, even though it only has one term in it. So polynomial is kind of an umbrella. It has to be a function with real coefficients. We just spent a little bit of time on imaginary numbers, but there can be no imaginary numbers in the function. And it has to have whole exponents. So a whole number is the number like 0, 1, 2, 3. So it doesn't include negative exponents, and it doesn't include fractional or decimal exponents like x squared. That's one, x cubed, x to the fourth. So I think the word polynomial makes us think of it has to be this really big function. It doesn't. Y equals x squared is considered a polynomial function because it has a real coefficient and a whole number exponent too. The characteristics of a polynomial function, I'd like you to write down what standard form is, even though I think you already know what standard form is, but it's just written from highest to lowest exponent. So it's just extending what we already know from standard form of a quadratic. You always put x squared first. If it's cubic, you're always going to put cubic, the x cubed first. And the graph will always be a smooth curve. And it will always be continuous. So you won't have any of these big gaps where you've got to pick up your pencil to get to the next section of the graph. It won't be something like an absolute value function where there's a jagged point and it changes direction. It won't be like a piecewise function where you start here and keep going. It's always going to be a smooth curve. Even a linear function is considered a smooth curve. It has no jagged points and it's continuous. So even a linear function can be considered a curve. That might be confusing, but some examples. Let's put linear function first, just so you know that linear functions are considered polynomials. So y equals 2x plus 8, that is a polynomial. So is y equals x squared. So I might only have one term, but that's still considered a polynomial function. And how about something that's not in standard form? So how about 3 plus 2x plus 9x cubed? That's a polynomial. It's just not written in standard form. Some non-examples. You can't have the square root of x. Can't have the absolute value of x. We've looked at those before. Can't have a reciprocal function like 1 over x. What else have we looked at this year? We're going to look at exponential functions. So I'm going to list y equals 2 to the x as a non-example because that's exponential. And how about something like 3x to the negative first power? That is a negative exponent, so that's no good. How about the square root of negative 4 times x? That's an imaginary coefficient, right? Because it's 2ix. So you can't have any imaginary numbers as coefficients. So we're just sticking with like linear, quadratic, cubic. We're not venturing into all these other functions in this little unit. So it's just important to know what is a polynomial, what are we going to be looking at, and then we're going to study a little bit how the degree affects the graph and the x-intercepts, basically. We good on that part? So the degree is the highest exponent power. So in the example that I just did, this is 9x cubed. So even though this is not in standard form, the highest exponent is x cubed, so this is called a cubic function. So you look at the highest exponent power, and that is your degree. The leading coefficient is the coefficient in front of the highest exponent term. So it's the coefficient in front of the highest exponent term. So it's not leading this equation over here, but the leading coefficient would be 9 because in standard form, 9x cubed would come first. In this one, the leading coefficient is 2 because 2x comes first, and that's already in standard form. What would be the leading coefficient of this second example where it just says x squared? What's the coefficient that's sitting in there? 1. So if there's no coefficient written, like in that example, the leading coefficient would be positive 1, and the degree would be 2. All right, so I'd like you to take a minute, look at these 4 examples, and decide if those are a polynomial function, yes or no. It's okay to be wrong, just write down your guess. Is it a polynomial function? So does it have a real coefficient? Does it have a whole exponent? If not, circle what's wrong. This is wrong. And then if it is, write it in standard form and state the degree and leading coefficient. There's only one of these that is actually a no. So 3 out of the 4 of them are yeses. They have real numbers as their coefficient, and they have whole exponents. So there's only one of these 4 that is a no. So the other 3 are yeses. Even though there's something funky about each of them, they still are polynomial functions. There's only one of them that has a bad trait, that it fails the polynomial test. So I'm just going to give you a minute to think about them on your own, and then I'm going to put them. All right, so the reason why number 1 passes, you may have thought about pi for a second. Pi is just irrational, 3.14159, but it's still a real number. I can plot it on the number line. So they all have real coefficients, and they all have whole exponents. So I wrote down what standard form would be, and the degree would be 3 from the x cubed, and its leading coefficient is 2. So in standard form, that 2 should be leading the equation. Number 2, it's fine. It just was not in standard form. Just have to rearrange it. So the degree is 7, and the new leading coefficient for standard form is -3 is the correct answer. Number 3, you might have thought for a second about either the 1/2, that's a real number, 0.5, or negative square root of 3. So as long as the x is on the outside, that's just a number, 1.7. It's irrational, 1.7 something. The negative sign just makes it negative 1.7. If that negative had been under the square root, or if the x had been under the square root, then it would have failed. But because it was a negative 1.7 times x, it would pass. So it's important to know what fails and what passes as a polynomial. That's kind of like a first big idea. And this next piece we've been doing all year. There's something called direct substitution. It's just substitution. F of 2, you're going to plug 2 in and just see what you get. There's a topic that we're skipping this year that's called synthetic substitution. You'll see that in pre-calculus. We just don't have time this year to do synthetic substitution and synthetic division. So if there's a couple of you that want to see it, I could show you that other method just for, hey, just interest. But this direct substitution, plug in 2, see what you get. Plug in -1, see what you get. And then for 0, you got +1, right? Okay. So this next page, it looks like a lot of work. It's not. It's already vocabulary that you probably know. We've talked this year about degree of 0, 1, and 2. We just call a degree of 0 a constant function. We talked about that in linear times, like y equals 3. That's a horizontal line at 3. No matter what I plug in for x, I always get 3. Degree of 1, that we call a linear function, like y equals 2x plus 5, something like that, linear. And we just spent kind of 2 units on quadratic. So that should just be, hey, yeah, I know what this is. Let's say y equals x squared. So number 3, I think you know, is called cubic, but if not, that's a term that you need to know as a vocabulary word if you've never used cubic. Let's make up a function. How about 2x cubed plus 4x or something like that? As long as the highest power is 3, it doesn't really matter what else is attached to it. It could just be like up here, this was just x squared. But I like kind of throwing in other terms so that you don't get confused. This is still cubic. The next one you've probably not heard of before, but it's called quartic. So that would be a nice to know vocabulary word. I might not throw that one on your assessment on Friday, but when you get to pre-calculus, you're going to have to know cubic and quartic pretty fluently. So like y equals x to the 4th. Anything higher than 5, we just call like 5th degree. So you could call it 5th degree, 6th degree, 7th degree, like 2x to the 5th plus 9 or something. I mean, you could write nth degree here. So a 10th degree polynomial, a 12th degree polynomial, there's no special name for it, but you can go higher than 4 or 5. So I think you know most of those words. They're not surprises, just using the degree to identify the name of the polynomial. That's kind of important. And then the number of terms, I think you already know that one term is called a monomial, but I haven't used that word a lot this year. I've used binomial a lot, binomial, and I've used trinomial a lot. So, you know, bi just means there's 2 terms. Tri means there's 3 terms in the function. 4 and above, they just call a polynomial. So that's kind of like, oh, polynomial means, you know, more than multiple. So it'd be just kind of nice to know that there's some specific names for functions. So let's see, a monomial, we could say like x squared. A binomial, 2x plus 5. Actually, I should not write y equals. Trinomial, x squared plus 2x plus 1. 3 terms. I don't know, polynomial, x to the 4th plus 2x cubed plus x squared minus 7, something like that. So that was a lot of writing. I don't think that's a lot of new vocabulary for you, but math sometimes is building your vocabulary so that we can talk about things with each other. So I'd like you to just practice quickly on your own 1 through 5. You don't have to put them in standard form to do this, as long as you're paying attention to the degree. You're going to name them using their degree name and the number of terms. So for example, number 1, the degree of this is quadratic. So I would call this a quadratic trinomial. So you're using like an adjective of the degree to describe how many terms it has. So that's called a quadratic trinomial. See if you can just kind of quickly do the others. So you can check your answers to those. So not earth-shattering vocabulary, but just being, you know, responsible now for a couple additional words in your vocabulary. If you haven't used quartic before, if you haven't used monomial before, those are the only 2 that I haven't really said this year yet. Any questions on those? Kind of make sense? So just being able to say that, yes, this is a polynomial, this is standard form, and this is its name. It's a cubic binomial. Like, you'll sound so smart, right? Because you're, oh, it's got 2 terms in it, and it's got a degree of 3, or you could just say cubic binomial. See, it just like tightens things up a little bit for you. Okay, the last piece that I wanted to go over, again, this is not new because we've been doing this with quadratics. It just is extending into higher order. You do the same type of operation. So we're going to do an addition, subtraction, multiplication together, and then stretch our legs for a little bit and come back in and try some more multiplication and do a graphing exploration on the calculator. So this is new. This notation you might not have seen before. So up at the top, if you want to add 2 functions together, instead of writing f of x plus g of x, and this extends to like the PSAT or the SAT, I could just write this as f plus g of x. And all that's saying is just add the 2 functions together. But if you see this notation, you might be like, what? What does that mean? It just means add them together. F minus g of x, it just means subtraction. F times g of x just means multiplication. There's one that I left off that I usually cover. Well, we're going to do division, but there's something called composition. So if you want an extension, I can show you what a composition of functions means. Because that's kind of something I'm leaving off this year, but in pre-calculus, you'll use composition of functions. But this is called combination. So I'm adding them together, combining them. Addition. We already know how to do addition because we've been doing the same process for quadratics. If you see a like term, you're allowed to add it together. And I'm going to do it in standard form. So I look for the highest power first. So I'm going to add my cubics together first because I want to write my answer in standard form. So kill 2 birds with 1 stone, do the highest first. So I'd have negative 2x cubed. I like to cross them out as I go, but however you like to stay organized. The next would be 3x squared, right? And it has no extra like term to add to it. So just plus 3x squared. I'm going to cross that term off. And then it looks like minus 3x would come next. Cross that term off. And then I have a 4 and a 17 that can get added together for 21. So adding should not be something really new because you've been doing it all year. It's just extending it to, oh, I got a higher power and I got to put it in standard form. You want to be careful with subtraction with parentheses. Before I even start the problem, I just like to rewrite it without any parentheses. So like, I don't have to rewrite these terms, but over here, I would rather rewrite this as negative 4x squared, negative 10x, and negative 3x cubed so that I know that I've already used the negative sign and I can just circle to combine my like terms now. So I'm going to skim for the highest term. It looks like it's that 5x to the 6th, right? So 5x to the 6th comes first, cross it out. It looks like the x cubes are going to come next. If I have negative 3 of them and an additional negative 3 of them, I actually have negative 6 of them. So you don't change the power, you just change the coefficient. And then it looks like my x squared terms add up to 0, right? Positive 4 and negative 4 adds up to 0. And then it looks like I have negative 10x and negative 20. So it's not a challenging operation because you have to memorize this big rule, but what makes it challenging is reading your own handwriting, staying organized so you don't miss a term because that'll throw your whole answer off. So just do it slowly and methodically. I'm just going to skip examples 3, 4, 5, and 6 because I'm going to do those when we come back in. I am going to ask which operation is commutative. You might not have heard the word commutative this year. It just means the same forward as backwards. So A plus B is the same as B plus A. Addition is commutative. Is subtraction commutative? No. 4 minus 6, 6 minus 4, it doesn't give you the same answer. I talked about properties a lot last year, and I kind of skipped that this year, but commutative is important, same forwards as backwards. Okay, the last one I want to do before we go on our walk, and then I'm going to have you do some of these on your own. I'm skipping 7. You already know how to FOIL. You can do that when we come back in. I want to show you example 8. It's a binomial times a trinomial. So I'm just going to show you the box method in case you like that for organization. You are going to multiply x plus 2 times x squared plus 3x plus 1. To me, the box method helps you multiply because you have to multiply everything in this one times everything in this one. I personally don't use the box method. I'll show you my method in a second. It's just multiplying and keeping track, but now I just have to multiply. X times x squared is x cubed, right? X times 3x is 3x squared. X times 1 is 1x, or I could just write x. Now I'm going to do the second row. 2 times x squared is 2x squared. 2 times 3x is 6x. 2 times 1 is 2. The nice thing about this is your like terms are going to be diagonal from each other. So see how my final answer is going to be x cubed. I have a total of 5x squared. I have a total of 6 plus 1, so 7x, and then plus 2. To me, the box method just helps students stay organized. But if you are organized in general, I'll show you the method for if you want to skip the box method. Can I turn the page and just show you one more different method? Just write this one down. Maybe you'll like it. Maybe you'll want to do the box method. I'm going to do number 9 with you, and then I'm going to leave number 10 for you to try on your own, maybe the box method. I don't know. X plus 4 cubed. I'm going to write that out 3 times. All right, my first step is to do some FOIL. I have to do this first 2 together using FOIL, then I'll do the last one at the end. So if I FOIL out x plus 4 times x plus 4, I'm going to get x squared. And then it's going to be 4x plus 4x, right? So plus 8x. 4 times 4 is 16, so plus 16. So I still have this x plus 4 over here. Perfect one for the box method now. I just want to show you if you don't want to write out the box, all you want to do is first take these 3 terms and just multiply by x. So I'm just going to multiply them out. X cubed plus 8x squared plus 16x. All I did was I took these 3 terms and I multiplied each of them by x. Now I'm just going to repeat that process and do the distributive property again. Take these 3 terms, multiply them by 4. I'm going to line up my like terms as I go. So I'm going to get 4x squared. I'm just going to line that up with my like term. And then 8x times 4 is 32x. And 16 times 4 is 64. It's basically just another way of doing the box method without writing out a box. X cubed plus 12x squared. Is that 48? 48x plus 64. I get the same results, but if you like kind of writing it out like the distributive property, or if you like organizing it in the box method, however you can keep track, it's a lot of numbers to keep track of. Okay?